Good morning, and thank you for attending our webinar today. I'm Janine Hightower, the Mapping and GIS Team Lead for NEI, as well as the Georgia Mapping and GIS Representative. We also have Dan Colbert with us today. Dan is the Senior Technical Sales Consultant at Trimble. Thank you, Dan, for joining us. In this webinar, we'll be discussing what's new with Trimble TerraFlex, as well as introducing you to Trimble SiteVision. If you have any questions, please drop them into the question box. We will have time at the end for Q&A. Dan will be walking us through the latest updates to Connect Maps and TerraFlex. After the enhancements, Dan and I will briefly introduce you to Trimble SiteVision. Before we get started today, we'd like to just do a poll question for everyone to see where everyone's at, if you're currently using a current workflow. If not, so if you guys wouldn't mind answering the poll question, we'll take just a few minutes. Great, thank you everyone for answering those questions. It looks like majority of our callers today are currently using TerraFlex. I'll go ahead and I'll turn it over to Dan.
Awesome, thanks, Janine. Yeah, thanks for everybody for joining us today. We're excited about some new enhancements that have been released very recently with our new field solutions. For those of you who aren't familiar with what Connect Maps and TerraFlex are, just a quick overview, that it's a web-based, easy to use. It's designed to be very easy to deploy to the field, but it's a field and office solution for capturing GIS data, where Connect Maps is the office side for authoring field data collection forms, field configurations, and then also for all the data processing. In the field, TerraFlex Mobile is designed for the ease of use, to allow the field users to get up and running, collecting good quality data with minimal training. It supports all of the common platforms, Android, iOS, Windows, and paired with the appropriate Trimble receiver, supports any accuracy requirements that your workflow requires. So just a quick overview of what Connect Maps and TerraFlex are, if you're not familiar with it. What I want to do is kind of step through some of these new features. I'm gonna do a live demo as best I can here. So up first is some updates to the Connect Maps functionality as it relates to background maps. We've added the ability to upload your own vector layers. That's actually been a feature in Connect Maps for a while now, but now all of those vector layers that you've uploaded and visualized on the web are now available to the field user to add additional context to the field data collection workflow that they're in. In addition, we've also added the ability to clip out the standard base map, the street layer, as a base map, so that the field user can add that sort of context to their workflow. So the vector layers are your own custom uploaded data, and then the offline base maps are the standard ones that are offered through the Connect Maps interface. So what I'm going to do now is show you on Connect Maps the background vector layer uploading. And I've already done the heavy lifting of actually uploading this data, and this actually came from shapefiles, and this is just a bunch of water system features. And the way to add these things is just on the table of contents to add data by importing from a file. And you can browse to a file and we support KML, KMZ, file geodatabases, and a zip of shapefiles as well. So uploading any of those files will automatically be spatially referenced appropriately. we'll take the coordinate system information that's stored with each of those and do our best to reproject them on the map here. And now that all of these layers are available in the office, a field user who has access to that same project now has all of those vector layers available to them in the field. The only thing that we don't support yet is that a field user can't click on a feature in the field and get kind of the additional context. That's another feature that will be coming in the future. But right now, being able to see those features in the field, especially maybe doing hydrant data collection, it's important to know where all the other water system features might be. And you can control the visibility of the vector layers. Let's say you want to turn everything but the water meters, off. You can have that. You have that full control in the field. So a great additional context for the field user. So that's the background vector map functionality that we've added. In addition, we've added the background base map capture. And if I zoom out here and let's say I want the field user to be able to take out this entire area. So my data here is in this particular area, but I want to be able to take out something more than that. So in that same plus button on the table of contents, I can click to create an offline base map, and then click and drag an area of the base map that I want to make available to the field users. I've already created one for us called the project area, which is already on the mobile device. So I'll turn this one off and show you what I've already captured. So this project area has already been created and is available on the mobile device. And if I flip back over to the mobile device and zoom out just a little bit, and in base maps, I'll select the project area base map that was created. And if I zoom out, you can see that the base map is all that's available to the field user. I can alternatively turn that base map back off so that you can see the full street maps when I get back into coverage. So it's a great way to take all of that data out to you in the field if you don't have an internet connection and you still need that background map context. So those are the two new kind of Connect Maps features as it relates to the background data. The next couple of updates are specific to the TerraFlex Mobile application. We're excited about the addition of offset functionality, the ability to remotely capture a feature using a laser technology rangefinder. We support the 200X and the 360B for this workflow. We're excited about the workflow in addition because we've made it what we're calling an adaptive offset method. So it's very easy. It's a step-by-step process for the field user to capture good quality data and offsets. And I'll walk you through that here shortly as well. And then the manual navigation waypoint. In some cases, users are given latitude longitudes on a printout, or are provided the location of a valve in just a latitude longitude. And you don't necessarily have that data in TerraFlex available to you in the field. What we've done is added the ability to type in a coordinate and use that as a navigation waypoint. So it's just a quick and easy manual way to use TerraFlex to navigate. So I'll flip back over to the field application, and I'll walk you through the offset process here. So in this case, I have a feature called hydrant. And if I tap on the hydrant to collect the feature, I can enter all my attribution just like I normally do. But if I enter into the geometry collection screen, there's a new icon down at the bottom. And if you tap the new icon, it'll walk you through the process of doing an offset. It asks you to move to the location you want to use, and we'll log our current position. And then what we'll do is we'll shoot the laser rangefinder. It's waiting for the rangefinder measurement, so I'm going to do that here while I'm sitting in the office. and it updates the screen with a couple of pieces of information. Not only your current location, but also the distance of your laser rangefinder shot, and it also indicates whether or not the accuracy meets your specified accuracy for that feature. That accuracy is actually a combination of the laser specifications as well as the GNSS accuracy at that moment. So we've rolled that all up together to provide a good picture of the quality of that position with all of the components included. At this point, I used a TruePulse 360B, which includes the azimuth. So I've got both a distance and an azimuth in this case. If I was using a TruePulse 200X, which is just distance only, I can walk through and do a distance offset, and the screen here will walk you through those processes. I've got two options at the bottom. I can accept this as a completed offset, or I can refine it. And what that'll do is it will ask you to move to a new location and take another shot, therefore removing the inaccuracy that's related to the digital compass inside of the laser. Because I'm in the office, I won't walk you through that one, but I'll just take one step back and accept the accuracy, or accept the offset, store the position, and store the feature. And doing an offset is just that easy now. It's a fantastic new feature, and I think a great take on the offset workflow for those of you who are used to using TerraSync. The next feature is the ability to enter a custom coordinate. Definitely not as sexy a feature, but if I enter into the map from the home screen and navigate to a coordinate, you have the ability to type in a latitude and longitude, hit the start button, and you'll get a navigation target, the distance, and then the navigation window will open up to guide you to that feature. So just a quick and dirty way to enter a navigation target and move on your way. So that's pretty much it for the updates to TerraFlex Mobile. What I'd like to jump into now is some updates to our Trimble Positions product, which is, if you're not familiar with it, Trimble Positions is an add-in for Esri ArcMap. It's designed to allow quick and easy movement between the field and your Esri geodatabase backend. So through Trimble Positions, we can create field-ready forms from the geodatabase schema for use in TerraFlex in the field. Once the data collection is done in the field, it will take that data directly from TerraFlex and import it directly into the geodatabase. There's no import or export that needs to be done. So it's a fantastic way to connect your Esri environment with a TerraFlex field environment. New to Trimble Positions in these recent releases is the TerraFlex offline workflow. In the case that your organization or your workflow isn't able to use the cloud as a means for transferring data between field and office, through Trimble Positions we can now exchange data between field and office without the use of the cloud whatsoever. That's why we're calling it the offline workflow. Another exciting feature is the introduction of the ability to post-process data that was captured with TerraFlex. We've always been able to do this with TerraSync in our legacy products, but we've added this now to Trimble Positions and TerraFlex so that you can capture raw measurements in the field for post-processing for those cases where you need good accuracy, but you don't have real-time corrections available to you in the field. And what I want to do now is just quickly step through the office side of setting up Trimble Positions, and then I'm going to show you a quick demo of the post-processing, just to show you how easy it is to walk through it. So like I said, Trimble Positions is an add-in to the ArcGIS environment. The office configuration consists of making a layer available to the field through a series of configurations, a configuration wizard, this project configuration wizard. In this case, I've only got one layer, the hydrant layer. I configure the layer settings, which includes the ability to specify all of these, the available metadata. So not only who it was collected by, what device you used, the estimated accuracy values, all of those things can be mapped to fields in the geodatabase. If you do have a real-time capability using the offline workflow, you can edit field configurations so that your users don't have to worry about configuring those things in the field. They can do that here in the office and just push it out to them in the field. And then finally, one thing that is available in Trimble Positions is the ability to apply geoid offsets from data that comes in from the field. So if you don't have, if your project requires MSL values, you can apply those through Trimble Positions. So when the data comes back in, we'll apply that geoid separation here in the office. And then finally, once all that's done, you're going to package everything up and check it out to a TerraFlex database. And all this is it packages it up into a single file that needs to be transferred over to the mobile device. And once that, and you can do that through any means possible, any means that you like. If it's an offline workflow and you can't use the cloud, you have the ability to plug your device right into your computer and just drag and drop a file. Otherwise, you can email it to yourself. You can do whatever you like to get that file out to the field. Once that's done, it's all set up for field data collection. The process is exactly the same as if you weren't doing post-processing. The user doesn't have to start any files. They don't have to start logging. They just start collecting data. The one addition that they'll see is the predicted post-processed accuracy values. So you'll see the real-time accuracy, this 92 centimeters and 1.1 meters horizontal and vertical, but below it, you'll see the predicted post-processed accuracy. So you'll know before you leave the field whether the data that you're capturing is going to be of good quality. Once you're done, you'll complete the field work, and there's an option to package up all of that was done in the field for sending back to the office. That will package up everything. So that includes the GNSS measurements, all of the features and attributes, and images, and anything that was captured. It was all rolled up into one, and then you send that back into the office. And that's where we'll take over here in the final step of the demo today. Is I've done all the field data collection, and now I want to check in a database from the field. So I'll do a check-in from a TerraFlex database. I've got 5 forms in this database, and I'll perform the check-in, and it immediately imports all the data into the geodatabase. But then I have a lot more information available to me in this what we call a session. And if I look at the features in the session, you can see that right now they're of insufficient accuracy. And all I need to do at this point is perform the post-processing. Post-processing is designed to be like you saw, just a couple of clicks. One thing that we've added is this post-processing profile, so that anytime data comes in from the field, you can process it against a pre-configured processing profile. So that means all the base stations are pre-configured. All of the post-processing settings are pre-done, so you don't have to do that every single time. It's all wrapped up into one post-processing profile. You can see that the accuracy of the data that came back was excellent. And now, if we look at the features, you'll see, and I purposefully screwed one up here so that we saw the difference. But if we come back and look, we can see that the horizontal estimated accuracy for those features that were post-processed is in the 2 centimeter range. And if we zoom in on one of these features, we'll zoom in on the southernmost feature here, we can actually look at the individual positions. So we have very fine-grained control over the entire post-processing environment and experience. The last step is to take the post-processed session and then apply those post-processing results to the features. So you'll see the current location of this feature, and as I click Update Features, you'll see that the feature is updated now to the new post-process location. And if we look at all the features, it's done, and all of those features are now stored in the geodatabase with high accuracy and include all of the metadata that you would expect. So all the correction source information, the estimated accuracy values, the dot values. So all of that still comes through and is updated for everything that was done during the post-processing period. So an exciting new update for Trimble Positions is the offline workflow, and then the ability to post-process data that was captured in TerraFlex. So a nice, easy-to-use field solution, and a nice integrated, easy-to-use office solution for high-accuracy data collection when real-time sources aren't available. At this point, I'm going to turn it back over to Janine, and we'll touch on a few things that are related to SiteVision. Janine, you may be muted.
So what is SiteVision? Trimble SiteVision is a high-accuracy augmented reality system that is ideal for use outdoors. It enables you to interact with your spatial data in the context of the real world. You can visualize your data, measure points, lines, and cut fill values using GNSS, electronic distance measurement, and augmented reality technology as you explore the project site. The SiteVision system is a lightweight handheld integrated positioning system which consists of the DA1 antenna, electronic distance measurement and a swappable rechargeable battery, Trimble positioning and correction services, which is Trimble Catalyst, GNSS technology, and Trimble Cloud Services, which is Trimble Connect. The SiteVision app running on a user-supplied Android device with an operating system version of 9.0 and above. Sorry, guys, my slide is frozen. Just bear with me a second. I'm sorry about that. There we go. So Trimble SiteVision, the why. More and more these days, data comes in such a rich variety. Interpreting the data is just as challenging as managing it. SiteVision works by removing the complexity when visualizing 3D data. And by using the latest in positioning technology, the demand for accuracy and reliability when visualizing 3D data is coupled with the rigid standards of the methods used to develop it in the first place. Pair all of this with a powerful cloud platform, and the SiteVision system enables the ability to share complex data with not only traditional consumers, but additional project stakeholders for whom the data is key to making decisions.
Yeah, and I'll just jump in here that the visualizing the data collected with existing high accuracy devices is something that's a bit foreign to a lot of our users, and SiteVision puts a new spin on that. Imagine standing out in the middle of a field with a paper map laid out on a table, and it's up to your imagination to translate the 2D drawings in front of you into what will actually become the project site or the final construction, whatever it is. It could be a new overpass. It could be a building. It could be the site view, the site of a new building. It could be a utility location. But either way, your ability to imagine that from 2D maps is limited, and SiteVision brings that entire experience to life. So you can see those couple of pictures off to the right there. On the top is what's actually there today, and on the bottom is what is likely to be there or as part of the project as proposed. So you'll be able to see exactly in context with the real world your 3D models overlaid to visualize that in a much more rich way, and allows It allows that data to be used by an entirely different group of people. So you can involve not only in the engineers, but also the project stakeholders and even the public. It's a great way to visualize 3D data inside of the real world.
SiteVision can be used in a wide variety of markets. Here are just a few. We're just going to go over the first three. Utilities, some examples would be to be able to visualize where buried lines are so crews can visually see any potential obstacles when digging, and to assess the best locations to place wind turbines, solar panels, or transmission towers. In the transportation space, see what an existing design looks like and what other assets might be affected, and compare existing infrastructure to original model for repair and maintenance. In civil construction, to assure projects are aligning with expectations and to measure cut fill required to support placement of structures. SiteVision can support all of these markets, so please feel free to check out the website to learn more about these. So Trimble's done a great job of creating a YouTube channel dedicated to the SiteVision app. You don't have to worry about copying this YouTube channel address down. We'll be sending you an email out that will have this included, but it's a fantastic place to go and learn more about SiteVision. So we've talked today about the new enhancements to TerraFlex, the ability to do laser offset. We really have some really great stuff right now with both of those. And NEI decided to come up with a current loyalty promo. And what you see on the screen is everything that's included. So you're getting the LTI laser, the Centimeter R2, the Nomad 5, TerraFlex, and we're offering this promo right now at $4,000 off the list price. So everything you see, $12,995, and it's just a super great promo. So we have some time for some questions that have been submitted via the question box, and I'll look through them and just pick out a few. Let's see. Okay, so here's one. I already own a copy of Pathfinder Office. How do I migrate over to Trimble Position? Is there a cost associated? I'll take that one. If you already own a copy of Pathfinder Office and you're current on your maintenance for Pathfinder Office, we can move you over to Trimble Positions at no charge, which is fantastic. If you have Pathfinder Office and you've let your maintenance slip, we can bring you up to date on Pathfinder Office and then move you over at the no charge. So there'll be a fee just to move you, get you current on your current maintenance of Pathfinder Office. So I hope that answers that question. See if I can find another one. Here's one for SiteVision. Do I have to be connected to the internet to use SiteVision? Dan, you want to take that one?
You bet. I'll jump in on that one. So the SiteVision doesn't require an internet connection in the field. You do have the ability to download a project and a 3D model ahead of time. When you head out to the field, it doesn't require an active internet connection. GNSS correction can be provided by satellite RTX, although it does work better when connected to the internet for the use of a VRS for positional accuracy. But there is no hard and fast requirement to be connected to the internet.
Thanks, Dan. Okay, we'll do one more. Can I do a laser offset if I'm running an iOS device with a Trimble R2?
Yeah, I'll jump in on that one too. Yeah, absolutely. I've been using my Android device, but yes, the offset workflow is supported on all our platforms. The only limitation is to make sure that you use, if you're using iOS, is that you use an iOS compatible LTI rangefinder. So in this case, the 200 series rangefinders are the only ones that are iOS compatible, but absolutely the rangefinder workflow is supported on iOS also.
Thank you, Dan. And we'll go through, if there are any other questions that are coming in, we'll go through and gather those questions and send those answers out when we send the follow-up email out to you guys. If you would like any information about anything that we've discussed today or to schedule a demo, you can reach out to your NEI sales rep. If you're new to NEI, you can reach out to myself or to the sales@neigps.com on the screen, and we will forward to the appropriate rep. We really appreciate your time today, and we're really excited about all of the enhancements and the newest product, Trimble SiteVision. Thank you.